Excuse me, sorry. We're going to go ahead and do 5.1.2 for Algebra 2, Semester 2. Do some trigonometry stuff on here. First thing I'm going to do, see if I can go down here, have some space. Yeah, I have a little bit of space here. Make sure. All right, we're going to go. There we go. Sorry about that. So you guys have probably seen this before. SOHCAHTOA. It's for trig. And then I'm going to cover two triangles. I'll make two triangles here. All right. So I'm going to use theta here as this angle, and I'm just going to use x for this angle. The reason why I'm doing two right triangles and talking about the different angles is because the perspective matters. All right, so for a triangle, we have opposite, adjacent, and hypotenuse for the side lengths. So the hypotenuse is always opposite the right angle. So on both triangles, we take the right angle and go to the opposite side. That is my hypotenuse. Now, when we talk about the O, the opposite side, well, the opposite side, they're talking about from the angle that you were talking about. So for my first triangle here, this is my angle, and opposite of that is this side. So this is the opposite side. And the adjacent, which is next to, is right down here. So adjacent's next to, opposite is across, and the hypotenuse is always across from the 90. So on this example, this is my opposite, this is my adjacent. Now, if I change my perspective, and now I'm looking at things from the x's point of view, well, opposite of the x is down here. And then adjacent is right there. So don't always assume that this side right here is the opposite. It's all dependent upon which angle we're looking at and looking from. All right, so it could go either direction here. It's just always whatever angle they give us, that's the opposite. And then quick here, this is saying that sine of theta is equal to opposite over hypotenuse. These are our basic trig ratios. So the sine of any angle is equal to opposite over hypotenuse. The cosine of any angle is adjacent over hypotenuse. And then our tangent of theta is equal to opposite over adjacent. All right, so if we have that, we're going to go scroll back up. Question 1 is find the length of B. Find the length of B to two decimal places. So we were trying to find this. All right. Now, what are we given? We're given this angle. All right. So we're looking at this angle. All right. So we'll call that our theta. And we're also given this. This side is across from the 90, so this is my hypotenuse. This side right here is my opposite. Right, so it goes across, that's my opposite. So I have opposite and hypotenuse. If I scroll back down, which of my trig functions has opposite and hypotenuse? Well, that's my first one, my sine. Please don't say sin, it's definitely sine. So sine is opposite over hypotenuse. So now that I've identified which trig function I want, I can go sine of theta equals opposite over hypotenuse. So I can change this and rewrite it as sine of 35 equals B over 25. Now I want to solve for B here. Well, what's on the same side as B? The 25 is. What's the 25 doing? It's dividing. How do you get rid of division? You multiply. And so my B is going to equal 25 times sine of 35. Now at this point, you can just plug into a calculator to get your, and then round it to 2 decimal places to get your actual final answer. Please make sure that you are in degrees. So on your calculator, and if you're using Desmos, you need to go to the top right, click the wrench, and at the very bottom of the little pop-up, you'll have a radians or degrees. You want to choose degrees. If you're on a graphing calculator or a one of those old OGT calculators, there's an option. Just make sure it says degree. If you get an answer that's weird, that doesn't make sense, right? So an answer that wouldn't make sense here is like a negative number or something. If you get an answer that doesn't make sense, double check to make sure you're in degrees. If you don't know how to do that on your calculator, just reach out to me. So we want to find side A. So we're trying to find side A. This is now my adjacent, right? Is next to. So it's my adjacent, it's next to. I still have my 35 and I still have my hypotenuse here. So I have now adjacent and hypotenuse. Which trig function is that? Well, that's my cosine right here. A and H, that's cosine. Set this up the same way. I just do my generic. Cosine of theta is equal to adjacent over hypotenuse. Cosine of 35 is equal to A over 25. Same idea. I'm solving for A. It's being divided by 25. I get rid of the division by multiplying. And so my A will equal 25 times cosine of 35. Again, make sure your calculator is in degrees when you plug this in. Where are they getting the 55 from? Well, if I know that all triangles add up to 180, right? So I know the 3 angles of a triangle add up to 180. I have a right angle, which is 90, so I subtract that, I get a 90. I'm giving a 35, and you guessed it, my remaining is a 55-degree angle. So this angle right here is actually 55 degrees. I guess technically I should write it in a different color. So this is my 55-degree angle. So it wants to know what sine is. Well, if you don't remember, sine is opposite hypotenuse. So from the 55-degree angle, right, from this perspective, what's opposite? Right here. So I know sine of 55 is going to be equal to the opposite, which in this case was A. And then it needs to be over the hypotenuse, which is still 25. And obviously we know A is an actual value that we calculated here. So there should be an actual number there. So what they did here is a little reminder that a triangle has 180 degrees inside of it. And we can subtract it to find it. And then remember that the opposite and adjacent will change depending upon which perspective, which angle you're looking from. All right, so we want to find sine of x. So I know sine of x is equal to opposite over hypotenuse. So from this perspective, opposite is down here, and my hypotenuse is right there. All right. Is there a way that I could solve for this third side? I have 2 of the sides. I don't have the third one. Well, if you remember our old friend, the Pythagorean theorem, a squared plus b squared equals c squared, where the leg squared plus the leg squared equals your hypotenuse squared. I could do 5 squared plus 7 squared and c squared. So I'm taking these 2 leg lengths. It's Pythagorean theorem. You've probably seen this before. I believe 74. And I square root both sides. So c is equal to square root of 74. Square root of 74 there. So for my sine, it's opposite over hypotenuse. Well, we've already identified what my opposite was, is down here, and this was my hypotenuse side. I used the Pythagorean theorem to solve for it. So this is going to be equal to 5 over the square root of 74. All right, so 5 is my opposite. And then my hypotenuse is the square root of 74. One thing that we should do, because it's improper to have a radical in the denominator, is I'm going to take that radical 74 and I'm going to multiply top and bottom by radical 74. So what it ends up doing, it makes it look kind of goofy, but we no longer have a radical on the bottom. So this would be probably the proper answer to this. All right, now I want to find cosine of y. Well, here's y. Cosine is adjacent over hypotenuse. Well, the adjacent I've already identified as my 5. And then my hypotenuse is the square root of 74. So it ends up being the exact same thing. So this is actually going to equal here as well. So both of these answers are going to be 5 radical 74 divided by 74. Now we want to find tangent of x. Well, tangent is opposite over adjacent. We already know the opposite is going to be 5. So this is going to be 5, and the adjacent is 7. And now we want to find the tangent of y. Where there's my y. That's my opposite. My 5 I already identified as my adjacent. So tangent of y is equal to opposite over adjacent, excuse me. And then I know my opposite is 7 and my adjacent is 5. So these are just the reciprocals of each other, which makes sense, right? Because they're just changing perspective. All right, so for this one, we are given a sine. And anytime you're given a trig ratio, sine, cosine, or tangent, you know you have a right triangle. I'm going to choose down here to be my theta. And I know sine is opposite and hypotenuse. So I know that this is going to be my opposite and this is going to be my hypotenuse. It's what's given. What I don't know is this adjacent side. So what I'm going to do is, since I have two sides of a right triangle, I'm trying to find a third one, I'm going to use that Pythagorean theorem again. 5 squared plus x squared equals 13 squared. So I have 25 plus x squared equals 169. Square root. We know it has to be positive, so x equals 12. All right, so now I have this side length is a 12. Oh, what did I just do? I have no idea what that does. That's kind of cool. All right, so now we have our three sides, and now we can find my cosine, which is adjacent. Oh my goodness. Forgive me, my handwriting's bad anyways. Add in this tablet, it doesn't get better. So we have cosine of theta, which is adjacent. Well, what's adjacent? Well, that's that side I just found, the 12. And then the hypotenuse is 13. And then tangent is opposite over adjacent. Well, my opposite is that 5. We already kind of identified that. And then my adjacent was a 12. That's all they needed me to do. Okay. Now this is talking about special right triangles of 30, 60, 90. That has a ratio. So the 30-degree angle is 1, 60 degrees is radical 3, and then 90 is radical 2. So these are all going to be a ratio. They're going to be proportional. All right. So they want us to use triangle A to find triangle B and C. Well, if I know that, I'm going to change the color here. I know that it originally started with 1. So how do I go from 1 to 7? You might say plus 6. I'm going to say wrong. We got to multiply. If we're talking about proportions, we should be multiplying. So for me to go from 1 to 7, I need to multiply by 7. So if I multiply this by 7, I need to multiply this by 7. If I multiplied all of these two by 7, I should multiply this one by 7. So triangle B has 7, 7 radical 3, and 14. So I kind of just use these proportions, these ratios, to find the next one. So this is a 20. I know it originally was a 10. All right, what originally was a 2. And so I would go ahead and just divide 20 by 2. And I get that 10 that I kind of snuck out. So they multiply by 2. So I'm going to multiply everything by 10. I'm sorry, I keep saying the wrong stuff. So those ones are pretty straightforward. All right, so now these, and this is just something you're going to want to memorize. All right, so you just sine of 30, sine of 45, sine of 60. Ooh, memorize and I get it wrong, huh? All right, so for a 30-degree angle, triangle, so this is going to be y. So I have this triangle, and this is my, and that we'll say theta is 30. So I know this is going to be 1. This side is going to be radical 3, and this side is going to be 2. How do I know that? That's because every 30, 60, 90 triangle has this ratio. It might be bigger numbers like we had up here where you multiply by 7 or multiply by 10, but this is the generic ratio. So I'm trying to find the sine, which is opposite over hypotenuse. This is my 1/2 that I incorrectly wrote before. The sine of 60, if this is the 30-degree angle, this needs to be my 60. So this is 60 right here. Well, opposite is radical 3 and then 2. So this is going to be radical 3 over 2. Cosine of 30, again, 30 is right here, is adjacent, which is radical 3, and hypotenuse. And if you notice, we have similarities. The sine of 60 is the same as the cosine of 30. And then using that same logic, I know this is going to be 1/2, but we'll do it anyway. So we have cosine of 60, well, that's adjacent, which is 1, and then opposite, which is 2. So 1/2. And then tangent of 30, that's opposite and adjacent. So 1 over radical 3, which we will write as radical 3 over 3. So this is your proper answer. Then on this side, if you do 60, it's opposite over adjacent. So this would be radical 3 over 1. Now for 45 degree, there's a whole other triangle. So if we, that's a bad one. That's not much better. So these are 45. That makes this 45. The ratio for a 45, 45, 90 triangle is 1, 1, radical 2. So we had 1 radical 3, 2 for 30, 60, 90. This is for a 45, 45, 90. So now sine of 45 degrees is opposite over hypotenuse. So this is going to be 1 over radical 2, which we're going to say is radical 2 over 2. Cosine, which is adjacent, is actually going to be the exact same thing. All those values are the same. And the tangent is 1 over 1. It's just a 1. All right. Angle of elevation to the top of. Okay, so we have a building and we have the ground. Funny how we end up forming a right angle, right? So we have the building, which we want to find how tall it is. That's going to be my x. All right. And then there's a point that's 1 mile, which is 5,280 feet away. And this is an angle of elevation, so you're looking at the top of the building. All right. So that angle of elevation, when they talk about that, that 2 degrees goes here. All right. So 2 degrees is there. How tall is the building? Well, I need to figure out which trig function. So here's my angle. What is the x? Well, x is across. It's my opposite. What is my 5,280? Well, it's next to. It's my adjacent. Which of my trig functions is opposite and adjacent? Tangent. So tangent is going to be my trig function. I'm going to have tangent of theta is equal to opposite over adjacent. Well, I know that my theta is 2 degrees, or that's my angle. My opposite is my x. That's what I'm trying to find, the height of the building. And then my adjacent is my mile, my 5,280 feet. And then I'm trying to solve for x, so I go ahead and I multiply. So my final answer is going to be x equals 5,280 times tangent of 2. All right, then you just plug that into a calculator. Make sure you are in degrees. All right, we'll do the last one. So we have a 50-foot tree. So we have a tree that's 50 foot. And it casts a shadow 75 feet long. So this is my shadow, and this is 75. What is the angle of elevation from that point? Okay, not the greatest. That's fine. Okay, so they're talking about this. All right. You want to know what this angle is? All right. So from this angle, what is this? This is my opposite still, and this is my adjacent. So I know I'm going to be using tangent. We just did it. But now the only difference is I already know what my ratio is. It's 50 over 75. So for us to solve for the angle, how do we get rid of the tangent? So when we did up here, how do we get rid of the 5,280? Well, we multiply. And the reason why we multiply is because it was dividing. If we have addition, we subtract. If we have subtraction, we add. If we square root. So there's always an inverse operation. It's no different for trig. So what I'm able to do here is do the inverse trig function. All right, and this x cancels here. So I'm left with x equals tangent -1. Now this is a calculator plug. On your calculator, you should be able to find a button that says tangent -1. And if you make sure you're in degrees, so I gotta make sure you're in degrees. When you plug this in, you should get a degree measure. You get some number that'll be in degrees, and it'll make sense, and that will be your angle. And they have a sine version of this, a cosine version of this. This is just the inverse, similar to how we divide when we multiply as opposites. Add and subtract are opposites. Tangent and inverse tangent, right? There's no fancy name. There's just a tangent, and then there's the inverse tangent, the opposite tangent. That's all it really is.